All right, hi everyone. So here is our bell work, day 69. So number one says to describe the sequence of transformations from rectangle ABCD to our new rectangle ABCD, but it's prime. That's what that little apostrophe means. It's read as D parentheses is really D prime. That's not something you'll need to know, but in case you were a little in case you were just wondering. All right, so we have our original figure here at the top and our transform figure at the bottom. So we just need to figure out how we got from the top to the bottom. So the first thing that I am seeing is that my D at the top and the bottom, they look like they're mirror images of each other. Mirror image. Okay, and when I think of mirror image, I immediately think, oh, well, it was flipped. It's a mirror image. That must be a reflection. Okay, so the first thing that happened is we reflected our original figure over which axis? It was reflected and it went from up to down. The only way you're going to get that is if you reflect it over the x-axis. If I reflected over the y-axis, then I would have this figure, but that's not what I have. Okay, this is not what happened. This is what happens. This dotted figure over here is what happens when you reflect over the y-axis. We want to reflect it over the x-axis. Okay, so this is not what happened, but let me show you what did happen. Let me erase this other stuff so you can see very clearly. All right, so what happened once we reflected over the x-axis, then you would have had this figure here. So this is what happened. Well, we're not exactly where we need to be. So we reflected it, that's one thing. But now we need to kind of turn it, right? We need to turn it in order to get it to this final stage, okay, where it's standing up straight. The only way we're going to be able to do that is if we turn it. So again, if we turn it, a turn is really called a rotation. So the second thing we did is we rotated our figure. And it looks like we're just rotating it, like literally what's happening is we have our D and our C, our A and our B. So now we're kind of just rotating it. So instead of having it this way, we're trying to make it so that we have our A at the top here. So we actually want it to go this way. Okay, we're gonna want it to flip all the way around. Okay, the only way that that is going to happen is if we are again rotating it. So let me write this a little better. So it's a rotation, and we just need to figure out how far we need to go. So let's see. I'm gonna show you a couple of things so you understand how like some rules for this, so you know what you're doing with the translation or with the rotations. All right, so let's just choose any one point you want to. I'll just choose point A, and I'll use a different color. Okay, so point A, our original point A was at 2, 5. Our new point A is at 5, -2. So we went from 2, 5 to 5, -2. So our original X and Y now become, you can see we've obviously swapped the X and Y, and that X value became negative. Okay, and here are the rules that you have to work with when you're working with the rotation. So you have these coordinate plane rules. So you have a 90-degree, you have counterclockwise and clockwise to deal with. Counterclockwise just means we've turned left, and then we have clockwise, which just means, of course, we've turned right. Okay, so then you go about your rules and things. So we could say So the ones that are going to be equivalent is we have our 90, 180, and 270. For the clockwise, you're just going to write it but upside down, or backwards. You'll have your 270, 180, and 90. And then you have your rules. Okay, so for the 90 and the 270 at the top, you'll go from xy to negative y comma x. For the both 180s, we go from our original xy to just making both of them their opposites, because you're just flipping it literally. And then at the bottom, we go from our original to swapping that order. Okay, so if you look, what we ended up having to do to get from one to the next is we're just doing it this way, but we're trying to say, well, we ended up going from xy to y comma negative x. Y comma negative x is this bottom one, so we have to choose either between 90 or 170. Well, we went to the right, so we turned our whole figure to the right, which means it's clockwise, right? Okay, great. So it's clockwise, but what I want you to see, so we know this rotation gives us a 90-degree turn, but then we also have to figure in what we did for our reflection as well, because there was something that happened there as well we haven't really applied yet. I'm just going to make that smaller to get it out of my way. So what we did, if you then look at what happened from your original A to this bottom A, in the second, in that first thing that we did with the blue rectangle, we had this be 2 comma negative 5. Well, when you have the 2 comma negative 5, it goes from xy to x comma negative y. When you have x comma negative y, you really don't normally have that, but you do know that what happened is you've reflected across an axis, which means you flipped it 180 degrees. Okay, so here we've also flipped it 180 degrees, and since we've done that, you need to add these two together. So you can have your 180 and your 90. So what we've done is we've rotated it 270 degrees, which matches here. We could have just said that, so that's good. We've checked ourselves. So we have our 270 degree overall rotation. All right, moving on to number 2, and I'm going to erase some of this stuff. If you need to write this down, you totally can. You can just pause it here, and then you can pick back up with me. All right, so I'll just go ahead and erase this. We don't need this for number 2. All right, so number 2, they just say to use the graph to answer the question below. So we went from this top triangle to the bottom. So again, very similar to one of the steps we did in number 1, is you can just go from B to B prime, and you see, well, it's the same. It's 2 at the top, 2 at the bottom. So when I say that, I mean it's 2 units above that axis and 2 below. So they're kind of mirror images of each other. Same thing happens with C to C prime. So if I have a mirror image, you know that means from our last problem, you've learned that means a reflection. And which axis have we reflected this over? Again, it was the x-axis. Over x-axis. And that's all you really have to do for this one. We've just reflected, it's a reflection over the x-axis. And that is all for today.